Hello folks. Our next little adventure is rotational kinetic energy, so that we can figure out the energy of a falling domino. So you might remember that kinetic energy for an object moving in a linear fashion is 1/2 mv squared, where m is mass and v is velocity. For rotational, we have the equivalent, 1/2 I omega squared. I is called moment of inertia, and lowercase omega is called rotational velocity. So when an object falls over, like this domino, it has its own kinetic energy. It's a little bit different than just a moving object. So here in green, I have the formulas for 3 different rotational inertia cases. One is just a point rotating about a center, and that is the mass times the radius squared. For a cylinder, it's 1/2 the mass of the cylinder times the radius squared. And for a rod that's rotating about the center, it's 1/12 mass times the length squared. All of these formulas are based on the basic mr squared formula. Now, for a domino, it's a slab, and it has its own formula, which is as follows. So for a domino falling the way we normally have dominoes fall, which we'll call I for its width, the formula is 1/3 the mass times the height squared plus the depth squared. Dimensions are shown right there. Now, as for omega, the rotational velocity, kind of looks like a W, but it's a lowercase omega. And it is the rotational velocity in the units of radians per second. Radian, of course, being a unit of angle around the circle. So if we have a disk or a circle or a ring rotating about its center, it will rotate, and let's say it's rotating once per second. How about that? 1 rotation per second. Then there's 2 pi radians in a whole circle. So the rotational velocity would be 2 pi radians per second. For a domino that's falling over, it's only going to rotate 1/4 of a whole circle. Make sense? So 1/4 times 2 pi equals 1/2 pi radians in whatever amount of time it takes to fall over. So what you're going to need to do in the following little video is time, how long it takes for the domino to fall over. So this is in real time. So ready? Here we go. Here it is again. Make sure you don't start the clock until the domino starts to fall on its own. Right about now. And here are the dimensions of my domino, so you can figure out the moment of inertia. You only need 2 of them. Which ones do you need?
So, to put it all together, you need to find the kinetic energy of rotation. So everything in orange that's here, once you calculate that, goes here as the moment of inertia. And everything in red is omega, the rotational velocity, right over here. Don't forget to square it. And then don't forget to multiply by 1/2 as well.
Make sure you show me all of your work, and we'll talk to you later.